Hello everyone, welcome to all of you on my YouTube channel. So here in this session, my dear student, I'm going to discuss about the diffusion of reactions with cylindrical pore catalyst. Already in the previous lecture, I have discussed about the heterogeneous uh, solid gas catalyst reaction, and I have derived different rate for for solid catalyst per unit volume, per unit weight, per unit surface area, all these. And after that I have derived the rate equations for rate of reactions for the solid gas catalytic reaction. Okay, so now from today, in this lecture, I'm going to start about diffusion and reaction within cylindrical pore catalyst. Okay, so let's try to understand the thing. Here in this session, I will be discussing diffusion and reaction within cylindrical pore catalyst. Okay, so my dear student, this is the basics of heterogeneous catalytic reactions. If you are able to understand these things, then the next part will be very easy for you. Otherwise it will be tough. Okay, so I want you to concentrate this on this topic at least. So after that the thing will come very easy. And here these topics particularly need some mathematical knowledge of differential equation, and after that you will be able to solve. Hope you all know the basics of solution of the differential equation of linear form. Okay, so let's try to understand. I understand. I am just letting you to understand with the help of this cylindrical pore catalyst. So this is a cylindrical pore, my dear friend. So just try to understand the basics over here only. So this cylindrical pore will be symmetrical. Okay. So that's why, I mean, in the gate examination, mostly symmetrical geometry will be asked. Okay. So here, CES, it is the concentration at the surface of the catalyst. Okay. And here, I am assuming here, it is x is equals to 0, and the length of the cylindrical pore is x is equals to L. Okay, so catalyst will enter over here and it will be traveling through this cylindrical pore, and after that it will be coming out of the cylindrical pore. So what will be happening over here, my dear son? Let's try to understand. Okay, so at a particular condition, at a particular length, I am denoting it with the help of reaction. Here it is a reaction. Why? Because the objective of our topic is, one is diffusion and another is reaction. So here it is reaction, are you getting? And uh, sorry, here it is diffusion. It is diffusion. Okay, when the catalyst will be entering, and here you can see there is a reaction. So in the pore, both these two will be occurring simultaneously. Okay, so my dear friend, both these diffusion and reaction both takes place simultaneously. It's very important. Both place, that is very important to understand. Okay, both takes place simultaneously. Okay, so next thing is that what happens over here, my dear student, as reactants enter, both the reaction and diffusion takes place simultaneously over here. Okay, so what happens over here, I am assuming a reaction A is getting converted into R, where reactant A and product R. Now if we apply the component balance, when we apply the component balance, what will happen, my dear student? Rate of flow at Z minus rate at Z plus dz. Here I am assuming this thickness is dz. Here it is z, and here it will be z plus dz. Okay, minus there will be a reaction rate of disappearance, because the reactant will be getting into the product, converted into product. So disappearance into dv, that is equals to 0, and it will be at a steady state, because most of the time gate will ask the questions on the steady state. That's why I'm also assuming here this is a steady state. It's a very important, that is in minus out. Here it will be in, here it will be out, and here there will be a consumption, that is equals to 0. Are you getting? Now, my dear student, can I write this term like this? That is equals to NA bar at Z minus NA bar at Z plus DZ. Okay, and divide. I am dividing it by dV, and minus of RA, that is equals to 0. Are you getting? So here this term will become minus dNA bar upon dV. All you know these things is just a simple mathematics. Minus of RA, that is equals to 0. Okay. Now, how can I write dV? So dV, can I write a dz? So can I write minus dNA bar upon a dz minus of RA, that is equals to 0. Okay. So can I write minus dNA bar upon AC dz, that is equals to minus of RA, and it's very important relation, and it is from fixed law of diffusion. Now it's very important, so you just try to remember these things. Now from fixed law of diffusion, what can you demonstrate over here, my dear student? Fixed law of diffusion say rate of mass flux, that is equals to minus Na, that is equals to AC and dE dCA upon dz. So can I substitute over this here? Once you will substitute, you will be getting here AC upon AC and dE del 2 Ca upon del Z2, that is equals to minus of RA. This AC will get cancelled out. So can I get minus of RA, that is equals to dE del 2 Ca by del Z2. My dear student, it's a very important lesson. Sometimes GATE has not asked this formula yet, but there is a high probability to ask these types of formula in the GATE examination. Okay, they will give you in MSQ, and after that you will be asked which of the following will be correct. Okay, so rate of reaction in heterogeneous is dE del 2 Ca by del Z2, that is second order partial differential equation. You can write second order partial differential equation. It's very important. Now, assuming first order reaction, I am assuming here first order reaction. So for minus of RA, that is equals to what? KCA. Are you getting? Minus of RA, that is equals to addition KCA. So can I substitute over here? KCA, that is equals to dE and del 2 Ca upon del Z2. Are you getting? So again, can I write my distance del 2 Ca by del Z2, that is equals to K by dE and Ca. Are you getting? Now here I am writing, can I write del 2 Ca by del Z2 minus K by dE and Ca, that is equals to 0. Are you getting? So can I write here del 2 Ca by del Z2 minus m square Ca that is equals to 0. Why I'm writing, I'm letting you to understand, because I have to go, make this term in the form of differential equation so that it will become very easy for you. Where m is equals to root k by d. It's a very important relation where m is equals to root k by d, and it is also very important del 2 ca by del z2 minus k by de ca is equals to 0. Okay, this is the basics of this heterogeneous catalytic reactions. It will play very important role in the successive lecture as well. So my dear student, next thing is that units of m, that is equals to, how can I write? So 1 upon m, that is equals to meter inverse, that is per unit length. Are you getting? So here you will be getting del 2 Ca by del Z2 minus m square Ca that is equals to 0. So you'll have to solve this differential equation. It's as simple. So can I write here d square minus m square that is equals to 0. So d is equals to plus minus m. We'll substitute over here. So can I write Ca is equals to C1 e to the power mz plus C2 e to the power minus of mz. It will be exponential form, in the exponential form. Wow. Now try to understand the thing. This was our cylindrical pore. It is z is equals to 0 and it is z is equals to L. At z is equals to 0, concentration Ca is equals to 0, and at z is equals to L, my dear student, concentration uh, Ca will have to calculate first thing. At z is equals to L, what will happen here? Just try to understand. At z is equals to L, can I write my distance del Ca by del z is equals to 0? Concentration will not vary with, like length. So just substitute these things over here. So at z is equals to 0, so Ca of z, that is equals to my distance C1 plus C2. Here can I write equation 1? Are you getting? And at z is equals to L, del Ca by del z is equals to 0. So can I calculate del Ca upon del z, that is equals to my distance C1m e to the power mz minus C2m e to the power minus of mz, and so del Ca by del z at z is equals to L, that is equals to C1m e to the power ml minus C2m e to the power minus ml, and that is equals to 0. Are you getting? It's as simple as that. So can I write here C1 e to the power ml minus C2 e to the power minus ml, that is equals to 0. Okay, C1m e to the power ml minus C2m e to the power minus ml is equals to 0. Next, my dear friend, what can I do here? So from here, can I write C1 e to the power ml, that is equals to C2 e to the power minus ml? Are you getting? So can I write here C1 upon C2, that is equals to e to the power minus of 2 ml? So C1 is equals to C2 e to the power minus 2 ml. It's just a simple mathematics. Already I've told you, you'll need some good knowledge of solving differential equation over here, and the thing will become very easy for you. Now substituting the value of C1 and C2 over here. So can I write my distance C2 into 1 plus e to the power minus 2 ml, that is equals to Ca naught. Why? Because C1 plus C2, that is equals to Ca naught, and here can I write C2 e to the power minus 2 ml plus C2, that is equals to Ca naught. So from here I can write this one. Are you getting? So can I write here C2 that is equals to Ca naught upon 1 plus e to the power minus 2 ml. Okay. And can I write C1 that is equals to Cas, and here it is, you can write Cs at the surface. Cs e to the power minus 2 ml upon 1 plus e to the power minus 2 ml. Okay. Next, we have calculated value of C1 and C2. We are having this value. Now, can I write my distance C at Z that is equals to C1 e to the power mz minus C2 e to the power minus of mz. So, can I write C at Z that is equals to CAS upon 1 plus e to the power minus 2mz, and it will get common e to the power mz plus e to the power minus 2 ml into e to the power minus mz. So finally, can I write C at Z that is equals to CAS upon 1 plus e to the power minus 2 ml. Here it will be minus 2 ml. So here e to the power mz plus e to the power minus m, and you can write 2l plus z. So can I write here Ca upon, I mean C at Z upon CAS. Okay. So that is equals to my addition cos of h of m of L minus Z upon cos h of m of L. This is one of the most important formula, and in the gate examination you need these things only. You don't need to use derivation and all, but if you are knowing concentration at a particular Z upon surface concentration Cs, that will be going concentration C cos of h of m of L minus Z and divided by cos of h of m of L. So this becomes very important. So here you can say concentration is function of my different m and z both. If any of two is getting varying, so the concentration will get changed. Okay, it becomes very important. So our concentration will be a function of z and l. Now next thing is that one thing for the cylindrical pore, you can see over here, as I have discussed, at Z is equals to 0, concentration will be Ca naught. And you know what happens when the catalyst will reach to Z is equals to L at the pore mouth, what will happen? It will be like that. The profile used to be like that, and it will becomes like that. So at Z is equals to L, that's why del Ca by del Z that is equals to 0. Why? Because slope is decreasing and the slope here it becomes constant. So just like in case of insulator, what we see at the surface of insulator, the temperature gradient will becomes 0. So this is the same thing that at the pore mouth, at the exit of the pore mouth, del Ca by del Z is equals to 0, and this profile looks like this. Okay. So up to this, I think everything is clear now. How I can, change the thing. Now, one more thing that becomes very important over here, how we plot the graph, because here concentration is the function of both m and z, and how the concentration is changing while changing the value of m and while changing the value of z. Let's try to understand it here. Just wait one second. Let me add the slide over here. Yeah, just wait one second. I'm adding the slide over here. One more, one simple thing that has been left in this topic is this one. So let's try to understand the thing. Yeah. So how will we plot the graph when m and z both are changing? So here, my dear friend, already I have told you The graph is a function of cosine. Okay. So here I'm trying to let you understand with the help of this particular graph. So here my definition C. CA upon CAS. CA is function of Z. So maximum concentration will be what? CA maximum tend to what? CA. So ratio will become 1. It will be the maximum ratio. Okay. That's why I am writing over here CA is function of Z upon CAS, and here it will be Z upon L, and it will be also equals to 1. Okay. Z upon L. So initially what will happen? Initially it will start from 1. It will start from 1 and it will decrease like that. It will go like that. Okay. Again, this plot will look like that. It's very important to analyze this plot, because once you are able to analyze this plot, most of the problem of this topic will get solved by itself. Okay. So, I am letting you to understand with the help of this particular plot, my dear student. Here, yeah. So here, what will happen, my dear student? Here it is M. So when we go from this direction to this direction, the value of M will be increasing. Are you getting? So M1, I am assuming 0.1. Here M2, that is equals to 0.3. If I am taking M3, here 0.5. Here M4 0.6. M5 0.7. M8 0.8. M9 0.9, like that. So the value of M is increasing. Okay. And here CA upon CAS at that will tending to 0.98 approximately. I will let you know why I am writing these things and what you can analyze these things. So my dear student, what will happen over here? One more plot I am plotting like this. Yeah. So I am just trying to say you about this particular plot. You can see here there will be some value of Z by L, and it will be very less as compared to this one. So what does this graph signify here, my dear student? As soon as the reactant will enter into this particular pore, as soon as that reactant will enter into the pore, what will happen? Ca by CAS by CAZ is getting converting into 0. Okay, it becomes 0. I mean, what happens over here? The when as soon as the reactant will enter into the pore, they will get converted, consumed into the product. So here the reactant will get consumed into the product. Okay, so M is very high. So M is very high here. Why? Because here concentration of the reactant is getting 0 as soon as it is entered into the pore. Okay, so M will be very high. Okay, so if you are getting, if CAZ upon CAS ratio is low, M will be high. Why? Because M is equals to, my dear student, root K upon D. M is equals to root K upon D. So here what you can say, so here rate of reaction is very high. Are you getting? What you can say here, in this particular condition, rate of reaction is very high for this particular curve, where Ca by Cas value is less. So here rate of reaction is very high, and rate of diffusion is very less. Are you getting? Can you understand these two things? Why? Because if ratio of Ca by Ca is very less, then definitely M is very high. And if M is very high, the value of M is mathematically that is root K by D. And if root K by D is maximum, then the rate of reaction K is very high and the rate of diffusion D is very less. So can I write resistance by rate of reaction is very low. Why? Resistance is equals to 1 upon K. Since K is high, are you getting? Since K is high, so overall 1 upon K will be low. Are you getting? So 1 upon K will be low. Again, I am letting you to understand one thing. Try to understand. If M is high, what you can identify? M is equals to rate root K by D. So K will be high and D will be low. If K is high, 1 by K will be low and 1 by K is resistance and it is low. Now, if D is low, 1 by D is high. Are you getting? And 1 by D is diffusional resistance. 1 by D is diffusional resistance, my dear student, and the diffusional resistance, it will be high. It will be high. So can I write here at this particular curve, for this, if you are writing Ca by Cas and it is Z by L, for this particular curve, it is resistance by diffusion is very high, so it is diffusion control. It is diffusion control. Are you getting? So again, I am letting you to understand one thing, my dear student. This graph becomes very important for you to understand the heterogeneous catalytic reaction. One region will be like this. There are several plots that you can draw over here and it gives a good insight for diffusion control region. So can I write this region is diffusional control? And this region is kinetically controlled region. Are you getting? So these two things is very important to understand you. This particular region here in this plot is diffusion control when Ca upon Cas plot versus Z by L plot, and it is Z. Here in this region, what happens? You can say M is high, and in this region M is low. Are you getting? This is diffusion control region and this is kinetically controlled region. Okay. So here in the next lecture, I will be discussing more about this particular concept because this concept is a little bit broad concept, and if you are able to understand this particular graph, again in the next lecture I will be discussing this graph again one more time so that it will be very easy for you to understand. And if you are able to understand this curve, then the problem they get even if in the back examination will become very easy for you to understand. Okay, so hope I have tried my best to let you understand this particular concept and hope you understood this concept as well. So if you are facing any doubt, you just put put your doubt on the sorry, on the comment box. I will be always ready to solve your doubt. Okay, so thank you and all the best.